Continuity Part 2. It's going to be a little recap of continuity, and I have two guests with me. I have Maddie and Laura. You can say hello if you like.
Hello.
So we're going to be looking at a few functions and talking about whether or not they're continuous, and if they're not, what type of discontinuity they have. So here is a function right here. Hopefully you can read this. It says g of x equals x squared minus 4x minus 3. And what do you think, Maddie? Is this a continuous function or not?
I think it is.
They think that's brilliant. It sure looks like it's continuous. It has no gaps in it or jumps, and I can draw it in one swoop without lifting my marker at all. And if you look at the equation, it kind of makes sense. The domain of this function is all reals, and there's no place that it's undefined. There's no denominator or weird square rooty things or anything like that. So here's another function. It actually looks like it's continuous, but I think perhaps Maddie knows better than that. What do you think, Maddie?
I don't think it is.
Why? What's going on with this function?
Because there is a denominator that can be made undefined.
Yeah, right. In the denominator, I have an x minus 5, and in fact, you're right. If I fill in a 5, it makes the denominator 0. So there must be something going on here. But in fact, it's not an asymptote, it's a removable discontinuity, which means there's a little tiny hole. I mean, the graph looks like it's continuous, but there's a little tiny hole at x equals 5. And how do I know that it's a removable discontinuity as opposed to an infinite discontinuity?
Because there's no asymptote.
Yeah, well, there's no asymptote there, and if I factor the top of this thing, let me factor the top, I have x minus 5, x minus... Oh, did I do that wrong? Wait, help me out here. What is it?
Plus 1.
Plus 1, thank you very much. Oh my god, all right. X plus 1. If I factor the top and bottom, I have an x minus 5 on top, and x minus 5 on the bottom. So in fact, I can remove the discontinuity. I have like canceled it out. I've removed the discontinuity of the place where it's undefined, and I'm left with this function x plus 1, which is what this guy looks like, except this guy has a hole in it. So this is a removable discontinuity. And I know it's removable because it makes the bottom 0, 5 makes the bottom 0, and it also makes the top 0. There's a factor on top that's the same. So here's one more function. This function, right away, you can tell that it's not continuous. There seems to be a break in it right here. There's an asymptote, and there's a break in it right here. There's another asymptote. And what kind of discontinuity is that? Little help, do you remember?
Infinite.
Yes, these are infinite discontinuities. So there's an infinite discontinuity at -3, and it looks like another infinite discontinuity at +3. A little bit messy there. -3 and +3, a little bit of a mess. So how can I tell, here's the function here, how can I tell from looking at the function that I have two discontinuities and that they're infinite? Any ideas here?
What?
Any ideas?
That you can make them undefined.
Sure, these 3 and -3 both make this function undefined, and if I factor the bottom, let's see, I have x plus 3, x minus 3. Yeah, now I can easily see that filling in a -3 or a +3 makes the denominator 0, makes the function undefined. And I have these asymptotes, or these infinite discontinuities. How do I know, though, that it's not a removable discontinuity?
Because they're not connected, or the top can't be canceled out.
Yeah, so yes, so I'm going to factor the top. I think I can factor out an x, and I'm left with an x minus 1. So neither of these places where the bottom is 0 also make the top 0. So these are both, nothing cancels out. These are both infinite discontinuities. Okay, last one. Here we go. It looks like a function. It looks like I have some kind of asymptote here, some kind of infinite discontinuity. This time I'm gonna check out the function though first. Let's see. If I factor this, I'm just gonna rewrite it as x plus 2, x minus 2. So I can see here that there are two things that make the denominator 0. When x equals -2, it makes the denominator 0. And when x equals +2, it makes the denominator 0. And when I look at the function, I can certainly see that at positive 2, here's x equals 2. I'll write that down. At x equals 2, I have an infinite discontinuity. But something must be going on at negative 2. Here's negative 2. What's going on there? It looks like it's continuous.
There's a
Remember
break.
this one? Yes, there is a break. It's a removable discontinuity. At x equals negative 2, I have a removable discontinuity. And how can I tell by looking at the function that it's not going to be an asymptote, that it's removable? Remember?
You can remove them.
Yes, because the thing that makes this 0 is also a factor on top. So in fact, I can remove that discontinuity.